Well, this is the Saturday before Christmas, the Saturday before Christmas, and I'm going to finish up Math 100. Then I will work on Math 105 stuff. Okay, so inequalities and two variables, our last section in Math 100. And we're going to graph linear inequalities and systems of linear inequalities. So for the first thing we're asked to do is to see whether or not these ordered pairs are a solution for these inequalities. So we're just going to substitute, again, the -3 for the x, the 2 for the y, and see if this is a true statement, and do the same thing here. Now remember, inequalities now are not going to be points along a line, although they may be in some cases, but they're going to be ordered pairs within a region, and we'll pick up on this as we go along. Well, when we do the replacement, we see in the first case that is -23 greater than 13, and the answer, of course, is false. While 58 is greater than 13, that one is true. So when we are graphing, and you'll see this here, make a little graph, and a couple of things for background that they will show us here in a few moments, that if we have an inequality, that if it's equal would look like that, and then we'd say if y is greater than something, we will be shadowing this upper region. And if it is only, let's say, greater than something, instead of using a solid line, greater or equal, we will be using a dotted line, and that will be one of the tools you'll have when you do your practice and later your quiz-mes. Now notice this line creates a border, which we refer to as a half plane boundary, that divides your plane into two parts. And all of these up in this region, any ordered pair, and there's an infinite number, are solutions, but none along this dotted line are solutions, because this would be only a greater than. Y is greater than something, then it's above the line. If y were less than something, it would be this region here. But if y were equal, then this would have been a solid line. Okay, but these are things we'll be getting as we move into the chapter. So for our first graph, and here again, this reflects on what we did earlier in the course, back in chapter 2. We can treat that as if it were y equals x. Our slope is going to be 1 over 1, and our y-intercept, since there isn't any, is going to be 0. So that would be a solid line like so, if that were x, y equals x. But now it says y is less than or equal to x. So a rule of thumb, that is sort of a shortcut, whenever we have that y is less than something, we will shade under the line. If y is greater than something, we will shade above the line. Now, suppose you don't know that rule of thumb. Well, then what you do is you do a trial point. For instance, if I use this point, 4, 2, where this is 4 and my y is 2, is that a true statement? And the answer is yes, that is true. So you would shade where your trial point is true. So we're going to have a couple of ways to show this. All right, let's continue. And if it's in function notation, it works the same. So they want us to graph this. Now again, what technique might you use? And that's what I'm going to show you. Well, since this is sort of in standard form, I'm going to use the x and y intercept t-chart. That if x is 0, y is going to be 8. If y is 0, x is going to be 3. So when we make our graph, we're going to plot 0, 8, 1, 2, 3, 4, 5, 6, 8 right there, and 3, 0, 1, 2, 3. Now we look at the kind of inequality sign that we have, and it's a greater than symbol all by itself. It's not equal to. So we're going to use a dotted line here. And I didn't make that too well, but you hopefully get the idea. Dotted line. Now, the big thing is, where do we shade? Well, they're talking about a test point. The test point I like the most is the origin, which is 0, 0. So here, if x is 0, this becomes a 0. If y is 0, this becomes a 0. Now, is 0 greater than 24? No, that's not true. So this test point is not in the area of shading. So we're going to shade above the line. Now, notice that this was a 3y is greater than a negative 8x plus 24, and that if we divide everything by 3, y is greater than a negative 8/3 x plus 8. So there's our y-intercept, and we're going to go over 3 up 8, which we can't do, so we're going to go over 3 this way, down 8, and there's our other point. So notice if we solve it and put it in slope-intercept form, y is greater than, and we had said anytime a positive y is greater than, we shade above the line. Okay, I'm assuming that's what it's going to tell you here as well. Oh, look, we did it correctly. Okay, so they're going to give you some tips for graphing, and let me just review those with you if you're taking notes on this. If you have y is greater than, y is less than, y is greater than or equal to, y is, that was less than or equal to, greater than or equal to, as you make your lines, for these where they're only greater or less, you're going to be using a dotted line. And depending upon the slope and other things. Now, when you have y is less than or equal to or greater than or equal to, for just the equal to, all of these, if y were equal to something, for this, it would be a solid line. Because they're saying that all the points along this solid line are included in the set of the answer region, the shaded region. While if we use a dotted line, those points along the dotted line are not included. This is sort of the old parenthesis, and this is sort of the bracket that we were using in earlier lessons. So, and then to determine where you shade, if you have a positive y, if it's greater than, you're going to shade above. If it's less than, you're going to shade below the line. Otherwise, you make a test point and see if that test point is true. If the test point is true, that's the region that you shade, that boundary that you have made by making a line. Okay, now of course graphing, we're not going to feature that using a graphing calculator, but we are featuring the graphing that you will be doing. Okay, for example 4, and again it gives lots of stuff here that you can read, but I will go over it with you as to how I would do it. Now when I see something like this, it's in standard form, I would make a t-chart. Especially since this and this are divisible into that. So if x is a 0, y is a -6. This is 0. Divide both sides by 2. Now if y is 0, this is going to be a +2. So now I can make my graph. -6, 1, 2, 3, 4, 5, 6. I put a dot there. 2, 0, 1, 2, a dot there. Now, this is only a less than sign. So what type of line do I choose from my tool palette? And the answer is a dotted line. Now, I'm going to try to make a dotted line here. Okay, that's not too bad. Now, I want to determine where do I shade? And again, a good test point is right there. 0, 0. That would be, this would be 0, this would be 0. Is 0 less than 12? The answer is yes. So you're going to shade where the test point is true. Now if you did it the other way, 6x minus 2y is less than 12, you might have solved for y. So I'm going to transpose that, and that becomes a 2y on that side. And I get 6x, bring the 12 over as a -12. I'm now going to divide everything by 2. And I'll write it this way. Y is greater than 3, this cancels out, x minus 6. So I'm going to put a dot at -6, that's my y-intercept. I'm going to do the slope of 3 over 1 up 3, which is right there. I'm going to use a dotted line, and where do I shade now? it says a positive y is greater, I'm going to shade above the line. So I've shown you two ways to graph this. You can use a t-chart since it was in standard form, or you could put it in slope-intercept form with a positive y. You could use a test point of the origin and see if that statement's true. Then you would shade where the test point is true. And you could use any other test points you want. Okay, and that's what we've done here. And that's what we had. Of course, theirs is much nicer. Now, here they're asking us to graph this. Now, do you remember this we called x equals a? What kind of line was this? Well, this was a vertical line equation. In the sense we were starting the review for the final. And where would that be on our graph? Well, it would be right there at -3. And is it going to be greater? Then that's to the right. And we're going to make then a vertical dotted line going through -3 and then shade this area. So this inequality, again, will be a vertical line going through the x-intercept, which is -3. And since x is positive, or I should say x is greater, we're going to shade to the right of it. Okay? And there's the graph of that. Now, for this next one, again, they're showing us a form of equation we had earlier, y equals b. This, you recall, is a horizontal line. Again, going through 4. Is 4 included? Yes, because of that equal sign under it. So instead of being a dotted line like the previous one, this is a solid line going through 4. And what does it say? Y is less. So we will shade underneath. Now, how about if we have systems of linear equations? That is, we have two of them and they want us to graph them. Well, again, they're both in slope-intercept form, I should say standard form. So let's do a little t-chart for each one. This will be the first one, and we'll call this one the blue area. So this is going to be 0 and 4, 4 and 0. And the other one we'll make red, this one. So here, if x is 0, y will be a -4. Now notice we might have to switch that around, but we don't have to worry about that because we're thinking of it as equal right now. And if y is 0, this is 4. So we're now going to graph. So I need 4. Let's see. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. Okay, now plotting the blue one. 4, 4. So it goes right there. and right there. Now we still have to consider what kind of line do we need here? A solid or a dotted? And the answer is a solid. So I will use a solid line for that. Now for the red one, what kind of line are we going to need for the red one? And the answer is a dotted line. So this is going to go through a negative 4, 1, 2, 3, 4, and a 4. So what I'm going to start off with is a solid line. Oop, I meant to make that red here. And I'm going to take my eraser and just erase it a little bit here. Okay, now I'm left with, what are we doing here? Well, whenever we have systems of inequalities, the word is and. And what did we say n was? Intersection. So our solution region is going to be one of these 4 regions. Okay? That's what we're looking for. Where do they intersect? Now, if they said it was union, you'd have 3 regions. And how do we figure that out, by the way? Well, the way I suggest you do it, and we'll use black for this, is in this first equation, the blue one, we're saying y, a positive y right there, is less than. So we're going to shade this region here. That is, this would be shaded, but we're not going to shade it yet. And then for the red region, and I guess I can use red for that one. Now a negative y is less than. A positive y, if it's a negative y is less than, a positive y is going to be greater than. So for the red one, we're going to shade this way. Now, they're going to tell you can use a test point to see if that's true in both of them. And I like my little way here too. Now, where do the lines intersect? Well, the red one and the blue one, they're intersecting over here. So this will be our shaded area. And you have a bucket of paint that sloshes on here to make this. So let's see what the book does. And this is a case where I probably should have looked at the book first here, but I'm doing this by hand. Beautiful. So again, one line went this way, one line went this way. Where do they overlap? Right where I had it here. Okay, beautiful. So that's basically what you're doing. And they're using these arrows to indicate which areas would be shaded. But when you merge the two, this one and this one, you get this as the area of intersection. Okay? Beautiful. Okay, now they're asking us to do this. And again, the way we graph that is we think of it as 2. We will graph this section first, which is this much, and then we'll graph that one. Now, by the way, when x is in the middle, what word is this? This is an and. That is, it's a conjunction. So, when you shade that, and again, this one is a dotted line, this one is a solid line. When you shade them, this is your area of intersection. Okay? Now, an interesting thing happens too. They're saying a system of inequalities may have graphs that consist of a polygon and its interior. The corners of such a graph are called vertices, that's the plural, and a singular point would be a vertex. We did a little bit of this in an earlier section, and let's see how much of it they want us to do. Graph the systems of inequalities. Find the coordinates of any vertices formed. Okay, we're going to graph this using standard form. This is a horizontal line. This is going to be it's in standard form, and it's just going to be y equals the negative x. Keeping in mind y is greater, so we're going to shade above. So this is what it looks like. Again, this y equals 3 when it's solved. That's this line. And then we have the two other lines, and it makes a little area right in there. Now, this is rather tedious because in this case, the vertices are on the grid line. And you could, if you're graphing this carefully, you can actually pick them out. But here, the vertices are not on the grid line. So what are you looking for? You're looking for a consistent point of two different graphs. That was from chapter 3. And when you solve, you get x is 3/2 and y is a negative 3/2. You'd be using these two equations, well, no, the first and the third. Okay? This equation, this horizontal line, doesn't come in. That would be used for the vertices of these two. But down here, you would just use equation 1 up here and equation 3. And you could solve by elimination, substitution, because graphing, again, it's not on a grid line, so it would be hard to get that. Okay, let's see where we are. We're up to 28 minutes already. All right, it showed you how to get the vertices. And then using a graphing calculator, that would be nice too, but we're not featuring that. Okay, this will complete our course, and we've done it, this last lesson, under 30 minutes. And it's just giving you a little review, which is nice about the textbook. And we will be having a test on Chapter 4. And later, we will have any extra time, we will review for your final exam. Again, you want to keep up with your practice and your quiz-mes. Remember, you're shooting for those 91 mastery points. Okay.